So today is October 4th, 2021, and with us today we have Lauren Maietti to talk to us about adjunct virtual machines. So over to you, Lauren.
Thanks, Bill. So, good morning, everyone. I'll be talking to you today about adjunct virtual machines. I am a software engineer with the ZAVM Development Lab, and let's get started. So, on our agenda today, I'll go through a quick introduction of what an adjunct virtual machine is. I'll go through some key concepts, show you how to set one up, go through the various control commands and how they affect our virtual configuration. I'll go through a short demonstration, tag my references, and we'll finish up with a short summary. So, what is an adjunct virtual machine? I'm sure you've heard before the term adjunct as it relates to ZVM. In this case, the adjunct virtual machine runs side by side with your principal user or configuration. So once you define a virtual machine in a directory, we'll call that user a principal. You can define an adjunct machine to run next to or with your principal that can help you debug a live system. So this can be a second level system that's running ZVM, ZOS, CMS, or any other programs in your principal configuration. And you can start up your adjunct to display the storage, modify it, run a program in the principal while keeping that principal's operating system intact. So these virtual machines, they have their own virtual storage or memory, their own virtual CPU. There's only one. We cannot define more at this time. It has its own virtual devices as well. You could IPL any sort of operating system, but it is truly intended to run CMS in your adjunct. One last little tidbit here is when your adjunct is active, your principal user is suspended and vice versa. So there can only be one. Next up are some key concepts here. So we've talked about this before, but a virtual definition block, or a VMD block, is used to define and control activities in a single virtual machine or CPU. These blocks are created for our guests, our virtual CPUs, and they're used by the dispatcher to run work on these items. So our virtual machine settings are defined through various channels here. So we have our directory statements, our configuration statements, and our commands that would actually change certain settings within our virtual definition block. And each virtual definition block that is defined by our principal user or that first user statement encompasses an entire virtual configuration for that user. So every virtual CPU you define or adjunct you define for a user defines its virtual configuration. So a visual representation of this. Here's our principal user. Its user ID is vmtest. It's running on vCPU 0. And in this case, the green, and you'll soon see other colors, will signify a VMD block that has been created. So here we see the cheese stands alone. We have our principal. It's running on its CPU. It's the originator. Nothing else going on just yet. So to make things a little more interesting, let's add a virtual CPU to our configuration. Here you can now see there is another virtual CPU defined. It has its own VMD block, and it runs with the principal. So what happens once we add an adjunct to this configuration? So as I mentioned before, adjuncts get their own VMD blocks, their own virtual CPUs, and they run sort of next to your principal. Much like your principal VMD block, an adjunct VMD block does have a few more defining features than, say, your virtual CPU VMD block might have. Something else of note here is the user IDs of the adjunct and the principal are actually the same. And I'll show a little bit of how this comes into play later. So how do we set these guys up? Let's find out. Here's a list of all of the adjunct externals. There's a features statement. There's a few directory statements that need to be defined. There's a set adjuncts command, an adjunct command, which is used just for controlling, and finally a query adjunct command. And to use all of these to set up your adjunct, you'll first want to enable the adjunct feature. In the system configuration file, the adjunct features statement is actually enabled by default. So if you'd like to make a permanent change to how your adjunct is enabled or disabled, you'll want to go into your directory and update that feature statement. Or you could use a set adjuncts command, which would enable or disable the feature dynamically. But again, if you want to make a permanent change, please do update that feature statement. Next, your directory statements. There's a user statement, which will define your adjunct template, and an adjunct statement that actually will include that adjunct template into your principal user's definition. Next, there's some adjuncts commands. As I mentioned, there's a start, an end, begin, stop, and a CP command. Finally, a query command, which actually gives a return code, which again, we'll get into a little bit later. I just want to drive this home. There is a feature statement. It's enabled by default, but if you want to make any permanent changes, please update your system config file. And a best practice, if you want to avoid any syntax errors, add a new feature statement instead of adding to your existing feature statement so you can pinpoint any problems. So here's a representation of your set adjuncts command. Pretty simple. It's issued by your system administrator. Again, any setting you make with this set adjuncts command will be reset whenever you re-IPO. Okay, so our directory updates. Say we have this common profile here that we can include in many different users. I'm just using this as an example so you know profile common 3 is defined in this fashion. To define our adjunct template, it might be a little non-trivial. It's defined as a user. We include that common profile, and then we can actually link a 191 disk. So a couple things of note here. That no log statement on your user line is required. We cannot log into our adjunct, much like we can't really log into a vCPU. It's not our principal. The asterisk in this link command doesn't actually refer to your Mr. Adjunct user here. It's going to refer to your principal because our adjunct is, in a way, part of our principal. And we'll see that on the next slide. My last point is this Mr. Adjunct user ID, or what appears to be a user ID, is more of an identifier than it is a user ID. And we'll see this here. So our adjunct template is added to a principal user through the adjunct directory statement. So using Mr. Adjunct user that we previously defined, here we have my operator definition, and I've added the adjunct statement and included Mr. Adjunct, which is, again, that sort of identifying term in that user statement. A few things to note here is the D option on the mdisk 191 statement. In this case, D stands for deferred, and basically what it does is we'll wait until either your adjunct or your principal is active and will link the disk to whichever virtual machine becomes active first. Something important to note is you don't really want to have write access to the same disk from your principal and your adjunct. So this is an overview of the adjunct command. It's a class G command. and it's used to control the adjunct either from the principal or from the adjunct itself. I wanted to take a little bit of a deeper dive into those commands and show how they affect that virtual configuration that I showed you earlier. So this might look familiar. Notice the user ID has changed here. This is our operator configuration before an adjunct has been defined. And in this case, I'll use the color yellow to signify which virtual machine is active and gray to signify which virtual machine is inactive. So the adjunct start command is really how things get going. It's sort of like a logon IPL for a user, but it also suspends execution of the principal configuration. And it leaves everything as it is with all these adjunct commands actually, which is pretty interesting. However, you have to make sure that your adjunct feature is enabled to get a successful start command. So here you can see a couple snippets. We have our query adjunct with our return code here. We know it doesn't exist just yet. Once we start our adjunct, you'll see in my demonstration, it sort of looks like your normal user IPL. Once we query our adjunct again, we see it's active. And if we try to start an adjunct that has already been started, you'll get this error message here saying it already exists, so don't bother. So here's your visual representation. Now we've started our adjunct. We see it's in yellow, so it's active. It has its virtual CPU, and our principal is inactive. It's been suspended. So now, say we want to get back to our principal. We're done for now doing our work in the adjunct. We can switch back using the adjunct suspend or stop command. They are the same. So this will reactivate your principal user. It picks it up right where it left off and suspend or put your adjunct in a soft stop. So from our previous slide, we had started our adjunct. Once we query it, we see, okay, it's currently active. We will adjunct stop or suspend our adjunct. Once we query it again, we see our adjunct is in the suspended state. And notice the return codes here. So here's that visual representation of our virtual configuration after the suspend command. We see our adjunct is now grayed out, it's suspended, while our principal is yellow, it's active once again. So the adjunct CP command is an actual way to issue commands to your adjunct while it's suspended from your principal. A caveat, your adjunct must exist and it must be in the suspended state for this command to succeed. So if we query our adjunct from before, we have just suspended it. So as you can see, it's in the suspended state. Now we can issue a CP command to our adjunct, such as the link command. And if we query our adjunct after we issue that command, we'll see it's still suspended. And if we query the link of the disk that we just linked to our adjunct, we'll see it is in fact linked. So how does this affect our virtual configuration? It doesn't. So that's pretty cool. All right, so say we're in our principal, we want to get back to our adjunct. It's as simple as adjunct begin or adjunct resume. And this again flips which virtual machine is active and which is not. So we query our adjunct, we see it's suspended, we begin, and we get our return code that our adjunct is now active again. And we can see through our picture here, our adjunct is in yellow, it's running while our principal is suspended. So say we're all done with our adjunct, we don't need it anymore, at least for a little bit. We can sort of log off our adjunct by using the adjunct end command. So this can be issued from the suspended state or the active state. In this case, I've issued it from the active state. So we'll query, we see we're inactive, we run our adjunct end command, we don't get any sort of response, but if we query our adjunct again, we'll see it doesn't exist, our return code is different. If we try to issue any other sort of adjunct commands, we try to issue begin, We see it doesn't exist, same with stop, and same with end. So once the end command is issued, our adjunct is now gone and only our principal user remains. Okay, so now for the fun part here, a short demonstration. Okay, so here is my principal first level user. Something I wanted to show you before getting into how this all works is how the query adjunct return code actually comes into play here. I have in my profile exec a few statements at the top. First, I query my adjunct, and I can use that return code, which signifies an active adjunct, to set a flag. Next, I can also try to identify where I am in my principal ID. Am I in my first level or am I in my second level? So now I can actually use these flags to define different capabilities or other functionality for these virtual machines. So when I'm in my first level and I do not have an adjunct active, something I like to do to keep my adjunct and my principal straight, I suppose, to figure out who's who, I like to set my screen to a full color. So in this case, my first level screen will be red. I access a few things. I set up my PF keys for my first level principal. I access my tools disks and I set my ready message. However, when I'm in my adjunct, you'll see I set my screen to yellow. I access a few other disks. I actually set my principals 191 to a different file mode, and I have a mini disk that I define as my A disk. Any way is right though. I link a few dump disks and I set my ready message. So if I query my adjunct, it doesn't exist just yet. So let's start it up. As it's starting, we can see we're first level, but our adjunct flag is on. We've linked all our disks, and now you can see my screen is yellow. So if I suspend, we actually go back to red. Once I come back, we're back in yellow. So how can we actually use our adjunct? By IPL my second level system, I have a nice exec that does that. So say I want to test something out. I've just written a bunch of new code. I've IPL'd in my second level system, and I want to see what my encryption is. Oh my goodness, I've hit a program interruption. What I can do instead of letting my entire system come down is I can start up my adjunct. Oh, I'm sorry. I want to begin it. I can open VM dump tool and I can trace. Oh my goodness, I've hit an operation exception in HTTP ENC at this offset for this instruction. And much like a dump, I can display the storage. You can use VM dump tool macros. So if we say VM dbk, we can use our block subcommand to see who the user is. And it's our system. So as you can probably get your wheels spinning here, this can be used in a lot of cases, while you're testing. You could be tracing through code. While you're tracing, maybe you want to see, how a block is defined, how a specific piece of storage has been altered, and you can go into your adjunct to do so. So let's just suspend our adjunct here. Let my second level system come fully down and back up again. Another neat thing you can do with adjuncts. So if I PA1 down to my first level system and I resume my adjunct, as I mentioned before, we leave things as is. So my VM dump tool is still up, but say I want to simulate a machine check from my first level system and see how my second level system handles that. I have a nice exec here that will do so, and it doesn't seem like anything's happened, but remember, we're still in our adjunct. Our principal is still suspended, which means our second level system is still suspended. So if I suspend my adjunct, we see we're still in our first level system, but if I begin to try to get back to my second level system, boom, there is the machine check we've just simulated. So you can do a number of different things with this sort of functionality, but that is all I have for my demonstration here. And here we are. So some references for using an adjunct. We have our ZVM library. You can find how to set up an adjunct in the CP planning and administration book, and the various adjunct commands I referenced today in your CP command and utilities reference. So in summary, our adjuncts runs side by side with a principal. Only one of these virtual machines may be active at a time. They can be used to debug a live system, and they can run anything, but it's really meant to run CMS. All right, so thanks everyone.
All right, then thanks very much, Lauren.
No problem. Thanks, Bill.
Thanks for watching. If you enjoyed this video, don't forget to like and subscribe to see more videos like this one. Have a suggestion for another video topic? Feel free to leave a comment below.